What? Oh no! I just realised I made it public. Oh well, what are you going to do? What are we going to do? It's a public one. I didn't mean to actually make this one public. Oopsie daisy. Well, I'm going to post it anyway over on the Patreon and just say it's accidentally gone public. I did not mean to make this public. Oh my god, what a silly Billy. Oh well, hello everybody. I'm just gonna... How do I get the link? I did not realise I accidentally... Oh, what a plonker. I don't know what I clicked. Builders live stream. Oops. So I managed to accidentally make this one public. I made it live before I made it go up. My bad. Sorry about that. But yeah, regardless, let's make a thingy. Oops. Oh well, what are you gonna do? Well, if you want to see more of these, you can. They're usually on the Patreon, but literally, oh shucks, I didn't mean that, but oh well. There we go. I'm just gonna let. One sec, everybody. One sec. Wait a sec, what YouTube channel is this on? I've just got to figure out what I've done. Oh no! It's all good. It's all good. One sec. One sec. Right, anyway, by the way, if you're, yeah, it's on the Museum of Everything Else YouTube. Okay, fair enough, whatever. So, by the way, there's a live stream, a Look Mum No live stream. I'm trying to do the Twitch thing. It seems to post better on there. So if you're interested in seeing a performance kind of live stream, there is one, because I do it every few months. After every single song I put out, I do a public performance live stream. So if you want to see that, it's on Wednesday over on the Look Mum No Computer Twitch. And but right now, this is a builders live stream. Usually these are for Patreon only, but I accidentally clicked public. So it's all good. It's all good. Just one sec. Ooh. So yeah, what we're going to do today is we are going to make, well, basically a little bit of a backstory. Last week I started this circuit and I accidentally fried the only chip that I have of it, so I had to order more. It's by Electric Druid. It's the VCDO, voltage controlled digital oscillator. Basically it's an oscillator that's digital, and it's got wavetables, and it kind of like goes through the wavetables, runs through them, and this, that and the other. And so that's what we're doing. I'm just basically gonna continue that. So what we're gonna do is, first I've got to remember what the heck I did. I haven't tried this out. I've literally just swapped this chip over, and I'm just gonna see if I actually try and remember where I got to before I accidentally fried the circuit, if you know what I mean. If you know what I mean. So, oh, it's there. So we got the and I think this is a fine tune. Oh, I've accidentally twisted it too much. But yeah, that's where we got to. It's basically got the output, which is, I'll run through, I'll just do a recap, a quick recap of where we're at. I'll just get the data sheet out again. Just find the data sheet. Is this the data sheet? Yeah, we've got the data sheet here. So basically, I'm not an engineer, no, I'm a backyard engineer. So basically, I just sort of make it up. So yeah, this is like I said, it was supposed to be a private one, but what can you do? It's already happened now. So I hope you enjoy this stream. I hope you enjoy it, and yeah. So this is what we're doing today: the Electric Druid VCDO. And if you are a Patreon, then you saw the last one of these. It was basically I started it, I got this far, and then I accidentally wired an output of the pin straight to the 12-volt line, and needless to say, that made it go pop, and it stopped working. So if you don't know, the VCDO is basically an all-in-one chip for a voltage-controlled digital oscillator. It's 1 volt per octave tracked as well. There's a fine tune, but we'll look at that in a minute. But so I'm just remembering where we got to. So yeah, this is where last time I crossed all the bits off, this, that, and the other, and what we were going to look at that point. So we tested out the frequency control. This is pin 1. So if you look at this chip, you can see like you literally can wire 0 to 5 volts to one of these, and you actually get the analog control. You get that control of whatever is going on in that pin. So we wired up the frequency control, which was this knob right here. Ooh, here we go. Here we go. Turn it up again. You'll hear it stepped. That's because it alters the frequency over semitones, so it makes a semitone over 4 octaves. So it's not a smooth one, which is a shame. I can see where the design idea came from, of making it solid to semitones for that knob, but it's not great for me. I wish it was a little bit smoother, but what are you going to do? Fine tune. We've got the fine tuning. You can basically tune it over 200 cents worth. So that's like, how much is 200 cents? Is that like, I've got to remember, I can't remember. Is it like 2, 3 notes, 4 notes? I can't remember. But waveform, so we wired that one in, and this is the one that scans through the different waveforms. And yet last time we did actually look at the waveforms on the oscilloscope. We may as well look at those now, if this has still got batteries. So this is the oscilloscope that I've got, that we were doing it with, and there was supposed to be a jumper cable that I had. Here we go. Just wire that up to the output, and we'll just have a quick peek at what is going on with the what's it called? The output. So we'll just wire that up, turn it on. Let's just plug it in, see what it's doing. You can see it there. You can see a little. It's not very high, but I'll try and boost it up a bit, and then we'll go through the waveforms. So yeah, you get the idea. It is that we're gonna unplug the oscilloscope for now. So yeah, I can't remember where exactly I was getting to. I remember, so basically I'm trying to design a module around it, and what I want is what I want to do next is basically the this one that goes over semitones. I don't think is musically useful, in my opinion. I may be wrong. So what I'm going to do is I'm going to try and step it into octaves. So not touching any of the code or anything, because you can actually get the code for this from the Electric Druid website, and you can program it onto a PIC chip. The PIC chip that is being used is I can't remember. I can't get it off. Oh, I don't know, but you can't. You know, if you're going to do it for yourself and you've got a PIC programmer, then you can download it. It's PIC 16F1847. And you can do that, but if you're going to design a module and stuff and plan to include the chip with it, then you sort of need to, you know, there's rules. There's certain rules with these sharing codes and stuff. Open source, sadly, it's difficult because of certain situations where it's being taken advantage of. So everybody's, you know, it's times are evolving, and it's fine. Obviously, the designers of these things want to, you know, they want to make it some sort of viable thing to actually keep on making these things. And nowadays, you know, there's a lot of situations where open source can sort of be taken advantage of in a way, and basically people just buying up these and selling them themselves with no reward or anything back to the original person that created them and stuff. So it's a bit of a tricky situation, and I'm sure some of you can understand where that is coming from, and that's why this is, you know, you buy it from Electric Druid. You've got to keep the community alive by supporting everybody, each person. And, you know, open source would be great if it was always like that. However, sometimes, you know, you know, it's an open discussion and stuff. Basically, since then, I actually got more of these. I really like these ones for these preset potentiometers for breadboard projects, because basically what happens is they're very fat and wide, so that means that if you put them on the breadboard and you twist them, they're not going to fall off or make a short connection. For instance, if you use like a more traditional thing like this, you plop that in there, and it's the fact is it's from a mechanical aspect. Oh, trying to get in, I've got a bent one. From a mechanical point of view, I'm trying to pop one in. They're all a bit bent. Come on, fit in there. So from a mechanical point of view, it's good, but it's a bit high, so it gets knocked. You knock it, and then you know, you don't know where it's gone. You don't know where it's going to be and stuff. So like, people do use these for breadboards, but I just don't think it's ideal. And there's lots of other ways of doing it, but these are what I'm sort of into now. You go through phases of what you think is good and what you think is bad, and you can take whatever you want from it. What are people saying? Since it's digital, can you create an algorithm to use the fine tune to get rid of a noticeable stepping? Yes, I'm sure you can, but like I said, it will be a conversation with Electric Druid for this one. But I'm going to try and deal with the limitations of it and make the most of it, because it has got a fine tune. So arguably, one sec, I'm just going to grab something and show you it. Just grabbing something from over here. So this right here is the 1222. It's the, oh, it hasn't got an Arduino in it, but this is the like Cosmo VCO that I made. It's a voltage controlled oscillator with a CEM3340. And the thing is with this, and this is why I'm showing you it, is because it's quite limited in its tunability. The reason why it's limited is because it makes it more musical, in my opinion, because the worst thing is if you're in a gig situation and you have this massive coarse tune knob that basically tunes through the whole range of the VCO, you accidentally knock that in a gig setting, then it goes out of tune, and you're spending a while trying to, especially if you've got a number of oscillators going on, you're spending a while trying to figure out why it sounds god awful. And it's because there's big fine tunes, and I find it a bit strange that oscillators are designed, some oscillators, quite a lot of them are designed with coarse tunes as the biggest knobs, because coarse tunes is just tuning over the whole range, and maybe that isn't what you need, because it just means that if you knock it, it goes out of tune, and then the tuning's just all awkward. So what this one does is it's got an octave, basically octave, and then this fine tune, you put it in the middle, it's C, you put it up, you put it down, that's a whole octave there. So even the tuning there, the fine tune is musical and stuff, and you could sort of get that with this. However, you won't be able to get a whole octave over the fine tune. You'll be able to get, let's have a look, 200 cents. So it's enough to compensate for certain tuning in your other bits of your synth and stuff. So Matt Keeler, yes, there is in certain designs. A lot of designs don't have them. For instance, I have my own homemade. Oh, I'm talking about open source, and this is what the thing is. It's like I have these braids that are modified, mutable instruments braids that are modified with a switch that basically switches between the Coarse tune big knob on the front and a preset potentiometer on the back. So I've sort of removed the Coarse tune, and you can flick it to a preset note which sort of locks it. But a lot of oscillators don't have this, strangely. They do in big combo synths like you know, the Moog Grandmother or something, and new ones. They all have these little fine tunes on the back, but it's still a very musical thing. And you know, having them like that, I just think it's a useful thing. So what I'm going to do is I'm actually going to try and step this knob into octaves. And basically what this does is it adjusts the tuning over 4 octaves of semitones. So what I'm hoping is I'm able to make a sort of stepped switch in a way. And what we're going to do is I'm hoping to use normal resistors, because in certain situations in an analog form you would need I'll just draw out the circuit first. I'll draw it out and then I'll show you what I'm talking about. I'm just going to draw a circuit. Oh. Alright, one sec. You're not going to see this until I do it. It's going to look like a sad little person. Plus, minus, voltage. So usually this is a potentiometer. It's not a person, but we'll just make it a person anyway, just for shits and giggles. That's where it's going. But this is your standard tuning knob on an oscillator. It goes between the positive voltage of whatever it is, and then it goes between the negative voltage. This could be a minus voltage, or it can even be ground. You know, it basically acts as a voltage divider. It basically divides the voltage between that and that. It just makes it come out. So if this is 10 volts, yeah, and this is ground, and you pop this in the middle, then it's like halfway between the two. You end up getting about 5 volts, and that's sort of how it works in a way. And this could be any sort of resistance, really, you know, within tolerances. Like you could have it as a bloody, I don't know, 10k, or you can have it as 100k or whatever, and it will do a reasonably similar job in itself. So we got that, but what we're going to do is, how do you make that stepped? Oh, look how dirty my nails are from working today. I'm gonna clean those really quick. Ooh, dirty nails. I've got dirty nails. I've been building all day, so just crud under my nails. Ugh. I don't know how people, I guess people just don't do like nasty work all day. I say nasty work, it's just like manual work all day. Anyway, so what we're going to do is, instead of having a potentiometer, we're going to pretend we have a potentiometer that has steps in it. So like, imagine you're like click, 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 click. And how do you do that? Well, basically it looks like this. So let's say we have, I don't know, so this is going to be, it's going to be 4 octaves. So you have 4, 3, 2, 1 and 0. That's 5 different steps you want to get to. So I'm just going to quickly do the maths, and I might not figure it out straight away because I may be out by it. But let's say we have, let's say this is a, oh no. Let's say this is a, okay. Let's say this is a, you won't get these aren't common, but let's say this is a 40k potentiometer. That means you're kind of like have, and then let's say there's 10k there, there's 10k there, there's 10k there, and there's 10k there. Basically, you're kind of wanting to meet in these little points where you're like 40k, I mean 30k, Oh, come on, come back, come back, come back. Oh, oh, come on, come on. Is it back? Oh. Right, are we back? I think we're back. I think we're back. Okay, okay, okay. Are we back? Hello? 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 Okay, yeah, I think we're back. I think we're back. Okay, so yeah, I'm sorry about that. Basically, I usually set up the stream and then I get everything set up and I sort of accidentally somehow streamed straight away. And basically, what that meant was I completely forgot to get everything else ready. I didn't plug the laptop into the charger. It's a laptop, yeah, but I didn't plug anything in, and hence I started without anything. So we're back anyway. So where were we? Where were we? So we are. Okay, so we're back here. Right, you've got to remember also, because at Patreon, I think it's sort of understood, but you know, like I started doing this out of a hobby. I didn't really have much electrical knowledge when I started. Well, I did. I was, you know, I took things apart, and all of this is basically from just messing about. So nothing super scientific, and it may annoy some people, but my sort of anecdotes and trying ways of figuring it out is not from a educated stance. So it's all just messing about and trying to figure it out. Anyway, so we've got this and we're getting back to it. So if you flick to this, you get like, imagine this is 10k steps in this 40k potentiometer. You have a whole 40k here, and that means you get the max. You get like 10 volts. Then you flick over here to 30, and then that is what, like 7.5 volts because it's there. And then you get to 20, which is halfway. That's 5 volts. That's the 5 volts we talked about. And then that's 2.5 volts, and that is 0 volts. That's ground. But in this situation, actually, we're this is when it gets a bit complicated. Sorry, I should have put 5 volts there because we're running on a 5 volt power supply because it's digital. Digital is usually either 3 or 5 volts, but so that in this instance, if it's 5 volts, this will be 5 volts. That'll be bad maths. Come on, quick maths, Sam. 2.5 plus 3.75 volts, 2.5 volts, 1.25 volts. I can't remember, and 0 volts. I think that's right. So what we need to do instead of that is imagine the potentiometer isn't even there, and we just get. The problem with writing on Lego is it gets all blotchy. So oh yeah, I can do it on this. So we imagine we're ditching the potentiometer completely. There's no potentiometer. It doesn't exist anymore. The potentiometer is completely gone. What is this? Well, it's the other way around now. Yep, I'm sorry. I'm saying it the wrong way around. So basically, instead, we're going to have 4 resistors. This idea might not even work. It might just go wrong. So we've got 4 resistors in a line. There's this is going to ground. That's the symbol for ground. Sometimes, I mean, there's lots of different symbols for ground, but I'm going to use that one. And then this one goes to 5 volts. And then what we do is in order to get the voltage from the pin. So this is the digital pin. We're gonna draw him like a happy dude over there. So there's the digital pin. In order to get the 3.75 volts, remember that was the 3.75 volts here on the potentiometer. We need to sort of go. He's like, I'm gonna go over here. But if he wants to be in the middle, if he wants to get like 2.5 volts, it's like, I'm gonna go over here. Then 1.25 volts, and then it's like, oh my god, it's all ground, 0 volts, no, sad. Even though he'll be happy because it will just be a low note. So yeah, what we're going to do is that, and then this is going to be 10k, 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 10k. We're going to make that, it's called like a resistor ladder, but you can't climb it because it's not very big and not very practical. So we're going to grab some 10k resistors. Got some sitting right here, actually. Okay, so we got what, like 1, 2, 3, 4. Okay, we've got 4 of these resistors. We're going to snip their legs off. Ah, don't snip me. Don't snip my legs. I need my legs, my beautiful legs. I don't know whether this is going to be a practical thing, but I'm doing it now, so whatever. My legs, oh no, my legs, my beautiful legs. Oh, my beautiful legs, oh no. It's like that bit in Forrest Gump. Right, okay, so we're going to go back up here. So it's this knob that we're going to turn into a stepped knob that we're talking about. So these are the voltages that I need to explain again. So this blue line that's going across the bottom is a ground, and this plus line is 5 volts. So it goes all the way over. So if you see here, there's this green wire that is connected to the red wire, the red line, and that's the 5 volts, and then this one is the ground. So we're going to remove this, put it, oh, I just pulled the thing off, didn't mean to do that. Going to go over there. So this is 5 volts. Ooh. And this is the ground. Actually, I'm just going to remove these right now. I'm going to make this a longer wire, actually. This might not actually perfectly work, so it's going to be a bit of a fiddle. So what we're going to do is we're going to put like these in like a ladder. So literally it's going to look like the picture. It's going to look like this, isn't it? It's going to look beautiful. It's going to look absolutely bloody beautiful. Right, so we've got the resistor ladder. Ooh. Oh yeah. Lovely jubbly. We're going to send this one to this side to ground, and then this side to the positive voltage that we were talking about. Now, this wire, hopefully, if I put it on any of in between, like here, we'll end up with those voltages that we were talking about before. I'm just going to quickly have a read. I keep hearing a trope that the right side of the brain is the creative emotional part and the left side is the ordered logical part. So if you write with the left, your right brain is the dominant? I don't know. Do you buffer the output on your breadboards for extra protection? Malatil, I don't buffer nothing when I'm experimenting. The thing is, it's like, what are you buffering it from? Like, this is just, I just don't think it's that required unless the circuit doesn't work. You're like, why doesn't the circuit work? Maybe it needs buffering. And there are some situations like the CEM3340 oscillator, you need to buffer the output or it doesn't actually work because you're sucking too much to the mixer. So yeah, we are gonna plug it in. It's gonna be completely hanging around. It's gonna go because it doesn't. Because when this isn't plugged into anything, this pin, it's just gonna go. Well, I might be wrong. Yeah, it's just like going. Can you hear that? Earth domination. Kill all humans. Humans must pass. Belonging to the epsilon quarter. Anyway, let's plug it into the lowest note. This is the lowest note, and this is the ground, and then we go up. Hopefully, this will be in octaves. So, trying to find a. Here we go. Oh, it is an octave. Oh yeah, can you hear that? I think that's it sounds a little bit octavey. That does sound reasonably octavey. I might be wrong. I've just got to double check. But Maletil, it's good that you're buffering it because yeah, when you plug in the 3340 unbuffered into something, it doesn't tend to work. And on the outputs do need a high impedance, or they get sad. Can you see the sun headline right now? What's that mean? I don't know. Anyway, oh, I see. Yeah, I get it. So what we got there, so what we need to do is turn this basically into, oh, I don't know whether I've got any. We're going to turn this into a switch. Ooh. Just so happens we've got some switches here. I haven't got like a, I just want something, so I'm going to use this switch just to test it, see what the heck happens. Let's see how it goes. So what I'm going to do is, you know what, I'm gonna super glue this onto a bit of Lego. I may as well not spoil it. So what we need to do first is we need to actually make sure, oh, snip that bit off. We need to make sure that it's only going to go, it's only going to go up. So this is a 12-way switch. You can switch it. You hear that? 12 ways, but we don't want 12 ways. We want 1, 2, 3, 4, 5 ways. So what we've got to do is they come with no, they don't. Where are they? Hey, there they are. They come with this thing, and it's basically a little sleeve, a little collar. I don't know whether it's a collar or a sleeve that goes into these little holes, and basically it stops it and basically limits it to anything between one switch and 12-way switches. So right now, if you can see, you can twist it freely through the whole 12 ways. If we put it on number 1, 2, 3, 4, I think. Number 4, it should be 1, 2, 3, 4, 5, and then it stops. You can see it. You can see the sleeve moving because it mechanically stops it from being able to go any further. So what we do is we usually bolt it onto a panel, and that holds the sleeve in, but we haven't got a panel at the minute, so we're literally just gonna bolt the bolt down like this. Ooh. By the way, if anybody's late coming to it from Patreon, I'm sorry, I accidentally set this to public before I even posted it. I don't know how I did it, but it's a nice, we're all having a lovely time, so I hope it's alright. I hope that's all good. So we got this, and we are going to, and also if you're over there, click through the link to the YouTube and join the comment section on the YouTube, because it's a YouTube link and I've just lost my page. So yeah, we've got this here. So what we're going to do now is I'm quickly just going to solder. You can see, you won't see on this picture. Oh, will you? Will it focus? Nah, but there's really faint numbers on here. It goes from 1 to 12. So we need to solder a wire from 1, 2, 3, 4, 5, and then the middle wire, which is actually the common one. So these all, when you twist it through, this one connects to all of them, depending which one the switch is. So I need to solder a bunch of wires, basically. Okay, so right, this is gonna get messy quick. By the way, you can use this. Sorry, you can use this for any situation. For instance, if you imagine this is an Arduino and you want to, you have a bit of code, and for instance you can't figure out how to do a stepped thing, and you want a stepped thing. This is the same thing. And if you want to have more steps, just add more resistors. You don't need to change the resistor value as long as you're within reason. As long as you're within reason, you can actually just keep on adding 10Ks, 10K, 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 and divide the voltage between 5 volts and 0 up to an amount that I don't know. You could test it, see how many you can go up to. But yeah. Anyway, for my hoarding, Craig, it's true, I am a hoarder, but also it's for all of the bleeding machines like the 1000 oscillator Mega Drone. I'm going to do a video, I think, on the 1000 oscillator Mega Drone, because I don't know how much it costs. I don't know how much I've spent on it. I've sort of done a reasonable budget, but I just can't keep track of it, so I'm going to add it up. I really don't know how much I've spent on it, and I think it's a scary figure. It's a very scary figure. Marek, Ant, you can also use a digital resistor. Yes, you can. However, the limitations that I'm working at with these things and these circuits is I want to, all of these modules and these things, I want to make sure that most of the components are very replicable. So for instance, if you buy a bunch of components for this module, most of them will go onto here. So it's the case of using a £2 digital potentiometer or using 4 1p 10k resistors, you're going to use the 4 10p 1k resistors. It's cheaper for whoever's looking at building it. For this job, if it's a more complicated thing and it makes sense to use a more advanced piece of technology, then yes, it makes perfect sense. But this, simple as. And plus you get the tactile feeling of actually switching, so you know which octave you're on, and you can do it by hand, counting by the clicks in your hand. Right, anyway, I'm going to quickly do this. So I'm going to make the common one grey. We're going to go for grey. Oh. Just going to solder this on really quickly, because this is always the boring bit. Ooh, baby, doing the soldering like this and that. Ooh, baby, soldering all day. What can I say? Right, there's one. And then we're going to use, I can't be bothered to get up again, so I'm just going to use 4 red wires. 4 red wires, you can't even see it, so 4 red wires. Ooh, 1, 2. Ooh, itchy back. It's bloody warm today. $1,024 is indeed the max amount of values. However, if you think about 1,024 values, it's a lot of values. Like, for your brain, like if you, even 256 is reasonably smooth to a extent on a knob. Depends what it's for, but. Right, anyway, I'm going to solder it on. So I'm just going to wet these. 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, I need another wire. Sorry, I know you can't see this bit, but the limitations of being up close but also having space to do everything is also a quick one. If you're working with breadboard, it's always good to have non-stranded wire, so single core wire. Stranded wire is, I don't know whether you've ever used stranded wire with breadboard, you'll know how frustrating it can be to try and get it in the holes, if you know what I mean. Right, so, okay, I'm sorry I'm using my teeth. It's I can't find my wire stripper. It's somewhere in the room, but it will take far too long to find. There's an art to using your teeth as well, by the way. Just make sure you don't touch the metal. If you're only touching the rubber, the sleeve with your teeth, it can go forever. Right, okay. I'm going to quickly super glue this onto a bit of Lego. So we got this here. I'm going to plop it right here. Oh, you can't see that. Plop it right here. Yeah, lovely jubbly. Oh yeah. So I'm going to put it on its side maybe. Don't think it's going to work on top. Oh no, it will. It will. So I'm just going to make sure I know which wire's which before I glue it down. Get a bit of glue. I'm going to find no super glue now, aren't I? God damn it. Where's the super glue? Oh dear. Okay, whatever. I'm just gonna whack on the hot glue gun and let it warm up whilst we're doing something. Hot glue gun is warming up. We'll look at actually fixing it down in a mo, but I'm just going to wire this grey one, which is the common one, to the pin. And I'm going to put the pin here so I can change it around. And then I'm just going to basically wire these in order on to the steps of the resistor, I think. And there. Just be careful not to pull it out. It's not stuck down yet. So let's find out if this is actually what is it? Octaves. Alright, so. I can't work out whether it's the wavetable overtones, but it seems that the top three are in tune, but maybe the bottom two, it's very hard to tell in the low frequency whether the overtones are telling you something different, because it would make sense if it was a very simple oscillator, but right now it isn't. But I'm going to take it as, yes, it works. It might not be 100% correct at the bottom, and potentially this may need, what is it? High precision resistors, but we're still yet to find that out. But the issue being is it's not you can be one semitone out just really easily, tiny amount. And what we could potentially do to actually solve that problem is by adding a 220 ohm resistor to the bottom, so we end up actually being halfway between values instead of near the top of one value. It might work, but I don't know whether it is an octave or not. So giving me the same value, so I'm not going to bother. One less resistor to worry about. Whatever. Yeah, I think it's definitely the overtones of the wavetable that's making it out of tune. So there's an octave there. Is the super glue? Is the hot glue? Ah, hot glue is running wild. Hot glue is running crazy. Pull up a load of hot glue down here. Oh, yeah. Whoa. By the way, I don't know whether anybody ever comes to the conclusion of this, but if you find that you are on your last glue gun, just push it with your finger. Push it with your finger in the middle, and you can use the last bit of glue. It's probably obvious, but you know, some people might not come to the conclusion. Right, I'm just holding on to it. Have you noticed something? Have you noticed something that is quite almost an octave? Almost isn't enough. It needs to be an octave if it's a semitone out, unless you mean it is an octave, as in like it's within a few cents. But have you noticed something? I managed to hot glue something without getting hot glue on my finger and going, wah! That's quite amazing, because that hardly ever happens. And trust me, if you've used hot glue before, or you use it on the regular, you know that is next to impossible to avoid getting your fingers burnt. Oh. Hello Lorenzo, I am building a VCDO. Yeah, the perks of streaming lucky. Because last time in the Patreon stream, by the way, Lorenzo, this is just a pure accident that it went public, but just rolling with it. I managed to fry it. So push it with a pencil. How does push it with a pencil? Oh, push it with a pencil. Yeah, that's a good one. I just got used to burning the shit out of myself. I know, same. That's why I was quite impressed by the fact that I didn't manage to get myself burned. Tyra Björman, you are telling the truth, and it's a very true trope that I shouldn't be using computers, but I do. I do. Neoman. I'm sorry if I'm pronouncing it wrong. Yeah, I am streaming. I usually stream quite regularly, but you know, was just an accidental public thing. But whatever, we're rolling with it. So there we go. It is there. We have got our octave. Yes, it's got an octave. We've got an octave. Right. Anyway, so back to the matter at hand. So that is that part explained and done. If you've got any questions, then please ask, because I'm sure there will be some people able to answer on the comments. So even if you have any questions at all that are burning about electronics, I'm sure there are some electronic engineers, probably much more educated than I am in the field, that will be able to answer your questions. We should get him to make one of those breadboard computers. Mufi, you're very true. I mean, I'm getting really excited to the end of the 1000 oscillator Megadrome, which is in, I reckon, in a few days. I'm gonna actually just switch off for a couple of days after that, and then I'm gonna get back, and I think I'm gonna really get into breadboarding and things and just more design. I've got this polyphonic idea and stuff like that I want to see, but I've got to get this 1000 oscillator Megadrome done first. So yeah. Anyway. Okay, so we have yeah, I know you're right. To be honest, the forum is sort of an extension of, but yeah, the Patreon's like just kind of the place to go and get the stems or whatever, and live streams and stuff. But the forum's where it's at to get all the technical talking. So we have here, I'm quite excited by this bit crush control, I've got to be honest. I don't know what it is about it, so I'm going to put a knob on that. A knob on pin 9, which is currently, where's pin 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's actually running free, so we're not actually listening to the wavetables like they're supposed to. I'm pretty sure that if I put that quickly... Oh. Getting a few more jumper cables. I'm pretty sure if I actually just wire pin 9, which is the bit crush cable, to the, it will sound a lot cleaner. Right, let's just try this. I'm going to wire the pin 9 to ground. Let's see what happens. That might be max. Oh, it sounds the same. Oh no! Oh, I'm a twat. I'm an absolute plonker. Did you see that? Did you see that? Oh, what a tosser. Okay, luckily I bought a few. I don't believe I did that. So basically what I did is this wire accidentally touched the minus 12 volts wire, which is there. It flicked over, so be very careful. I've managed to just pop that with, by my pure negligence, I managed to burn another one of these chips. I've never burnt so many chips ever. And then suddenly this project comes around, and the great thing about Arduinos is they do have circuit protection on them, so if you do that accidentally, it's not going to pop it. It's really a resilient development interface. But if you're working with the bare chips, you've got to be careful. Anyway, back to square one again. Get in there. Right, so we're back. How annoying is that? So I'm going to add another knob to this. I'm going to put this one back. I'm going to bring some, make it do its thing. That's heartbreaking because these aren't cheap, these chips. Oh. Where's my tweezers at? I don't even know where my tweezers are. I was started in such a rush because of this. I lost it all. I'm basically just making the connection of these potentiometers. 5 volts on this side, should be the other way around, and ground on that side, but whatever. And then wire that in there, and then get the power again. Ooh! want to see what that looks like on the oscilloscope. So this is the bit crush pin. Basically what Electric Druid has done is he's added a stepped thing to the output. So we'll wire that up there, get this bad boy on here. Right, let's see what this looks like when we adjust the bit crush. Adjusting the bit crush. Oh no, you're out of batteries. Ooh. Everything's going wrong. What batteries do you use? Where even is the oh, it's a USB, it's rechargeable. Oh, that's good news. Because I've got one here. I just got to keep an eye on the Wi-Fi dongle. I'm getting proper internet tomorrow. I'm very excited because I've been running on Wi-Fi this whole time. I mean dongle. Oh, is that... doesn't even fit. It's too far in. What piece of crap. Oh my god. The actual input for the charger is set too far in to actually plug it in. Oh, god damn it. I've got to take... That's what happens when you buy cheap, crappy things off the internet. Well, I've got to charge it some way. Yeah, it's an expensive pop, Garrick. That was an expensive pop. I'm just undoing this so I can actually charge the bloody thing. Oh no. Yeah, maybe we should make an oscilloscope. To be honest, Steve, I really want to make an oscilloscope because a lot of the oscilloscopes that are available on like Eurorack and stuff are actually the digital ones, the cheap digital ones, and I like this one. I personally really don't like the look of them. I really want an analog one, so I'm actually gonna get I've got a couple of small CRTs, and we're gonna make a digital, an analog one. Ugh, how's this gonna work? Doesn't even fit. What piece of crap. What? That is such an oversight. How could they... Look at that. What the hell? Look at that. You can't even plug it in. God damn. Analog oscilloscopes are definitely snappier. I just don't like the lag. It doesn't give you a real life view, especially if you're doing like analog circuits and stuff. If you wanted to actually see the smooth motions of it, then you definitely need to like well, it looks like I'm going to be turning this one into a module because there's no way in hell I'm putting it back in there. Okay. Oh, god damn it. That is so annoying. Got to take it apart to charge it. There we go. Oh my god, I didn't look at... I never saw that in the reviews, I've got to be honest. Right, so anyway, let's plug it back in. Right, so we're plugged back in. Let's turn it back on. Turn it up a bit. Ah, I'm flicking it wrong. Right, so let's just get it nice and... Oh! Damn, that sounds good with the bit crush. Holy crud, that is cool. That is really cool. Okay, so yeah, bit crush, definitely happening. The thing is, it's stepped, so I don't know whether I'm going to bother adding a CV control to it. The thing is when you're designing things like this, is you've got to weigh up usability to what's being on it. And the thing is what grinds my gears, for instance, Eurorack, it's always just so tiny and fiddly. There's too many knobs in the way, so it makes it very hard to use in a live situation, and it's just not ideal. So trying to prioritize what you make control voltageable with the jacks and stuff, and plus less jacks means it's a cheaper module to build if you're building a kit like the ones, because I don't include the parts and stuff. It's just thinking about the end user here. But the thing is, as I don't think that will be used that much control voltageable, because it's stepped. If you listen, it's not a smooth motion. I mean, maybe just add it as a CV in and not even mix it. I don't know. So what we got else? What else have we got? So there's also a sub-octave output, but I've only made the circuit enough for one output. However, we can probably listen to the raw output pin, but we'll have a look at what else there is. I think I'm just going to add. So we've got this. This is the red line. This is the frequency. This is now the octave. This is now the octave pin. This is the fine tune. So you're able to tune it between 200 semitones. So we've got the octave, the tune, fine control. I may add a trim pot to this. So mix it in with a trim pot, so you're able to fine tune it, so it doesn't have to be stuck at C, for instance, and you have to use an offset module to actually tune it if you're not wanting it to be banging C or something. Moofy, there's the octave divider. It's a digital octave divider here. For instance, in this one, Moofy, this is the CEM3340 module. This has got an octave divider. You can see these four resistors, these four 10k resistors, act as an octave divider, which means that you're able to switch between, and then there's a stable voltage, so you're able to choose the octaves that you want and stuff. So what we're going to do now is, I think we're going to have a quick listen to the sub-octave. So there's a sub-select control. This is the thing that actually selects between the waveforms, because this actually has two outputs. There's two separate oscillators going on. They're matched, but there's two separate oscillators that you can actually choose different waveforms for both of them. They're in the same tuning, but there's no detune between them, but you're able to have some outputs. So what I'm going to do is I'm going to put another knob on the sub-select. So we're going to find another 10k, 100k. By the way, a quick one. If you're working on any Arduino projects or anything like that, or if there's a module that's got Arduino projects and it says 10k resistor for the digital resistor potentiometer, you can get away with using 100k. You can get away with using pretty much any sort of resistor, because it acts like a voltage divider, so it doesn't really matter. Anyway, we've got this. So there's another 10k. We're going to add that to make the sub-select control, which is pin 7. I'm going to make another one here. Getting some wires here. Gonna wire this one up again, so we're able to. Come on, you pleb. Where's my tweezers? Where are my tweezers? I need my tweezers. Where'd I put my goddamn tweezers? God damn. Where the hell have I put my tweezers? Oh, I've got. That's the other downside of Lego, is you get your bloody wires stuck in them. But it's pretty good Lego. By the way, if you're interested in these breadboards and these power circuits, and there's also a proper version of this, they're going to be available on my store within the next few weeks, 3 weeks or so. They'll only be cheap because they're only small little things. So pin number 7, I'm going to wire that up to that. So this is now the sub-octave, and to quickly listen to the actual sub-oscillator, what we're going to do is we're going to find the input pin. This is actually going, see all of this gubbins over there, this is the output, and if I show you the schematic that we worked off, this is the datasheet schematic, this is the output. So it gets buffered, and it makes it, because the output is actually not, it's a pulse width modulated output, and that's another conversation entirely. but basically what this does is it adds a low pass filter to the digital to smooth it down to act more like an analog voltage. But what we're going to do is we're going to take this wire out, flick this up, and this is the actual output of the module. Oh god, where's my tweezers? I would really do with my tweezers right now. And in order to listen to the so I'm going to listen to the normal one, see if it's working. So this is the normal one still. So the normal one is still working. Now we've got to find where the oh, yeah, that's cool. Don't even need a mix. I got to put that on ground though. Make sure I don't pop it again. Okay, so where's the sub output? Oh, sub oscillator out, as I've crossed it out, is pin 16. So we're gonna unplug the output pin, which is this one. I'm gonna unplug it, plug it into pin 16, which is 10, 11, 12, 13, 14, 15, 16. That doesn't even sound like a sub. Ooh, look at that sine wave, all beautiful. Wonder if the bit crush works on it. Oh, it does. Look at that. You know what, I'm actually going to add CV to that bit crush. I think it's going to sound cool. It doesn't sound that stepped if you move it quickly. How many steps are there on the bit crush? The bit crush has 8 steps, and if you move it quick enough, it sounds sort of smooth. I'm sorry, I'm just reading really quick. Etch-a-sketches, oh yeah. Oh well, it's like that. I did that video on a plotter, which is basically like a control voltage etch-a-sketch, and I reckon you could get an etch-a-sketch, pop it on the plotter, maybe that'll do it, and reply to Black Knight Radio. I'm a little tired, yeah. I've been working all day, but I said I was going to do this, so I'm doing the live stream. I have very long working days. I've got to be honest, very long indeed. Even a Sunday, 7 days a week I work. Pretty 7 days a week from like 9 in the morning to what, 10 at night. Woo. Woo. Right, anyway, but you know, I'm pretty happy doing it. It's pretty good getting to build all day and shit. Even though I was doing a lot of building work today on the old museum. Anyway, so we have the sub octave, and as you can hear, that sounded pretty cool. It's got a sub, well, a sub sign. Sadly, the sub is stepped. The main one is actually a smooth transition between the waveforms. The sub is a stepped transition. So I need to figure out what to add CV to, what not to add CV to. But we've got it there, and it sounds like something. So I'm going to plug this back into the normal output. And what we're going to do now is we're going to make the 1 volt per octave circuit. I've just remembered basically I've got the washing machine is here. My girlfriend chucked me with the washing. I've just forgotten to put the next load on, so I'll be back in a couple of minutes. I'll write a little thing so people can come along and be like, back in 5. Gonna pop the washing on. 1 sec. Because yeah, I live in the top floor flat now, and it's like I wasn't gonna be carrying. It's like there's no lift and there's about 5 flights of stair. I was like, I'm not carrying the washing machine up there. So it's here. I'll get my light. Right, anyway, carrying on with this stuff. Oh, hello Cuckoo, how you doing? How you doing? This is a builder's live stream, and basically I accidentally put it on public. I wasn't looking, and I set it public before. Usually these are on Patreon, but yeah, accidentally. I don't know how it happened. Just somehow I don't know what happened. I did exactly what I usually do, but it just went public. Didn't make sense. But anyway, I'm back. The washing machine is on. We're back on the circuit. Oscilloscope is still on charge. Don't buy this oscilloscope because you can't actually charge it in the case. You need to remove it from the case, evidently, to actually charge it. But you know, we're back. What are we doing? Oh yeah, what was I doing? Of course. The next step is, so we've got the octave, we've got the sub thing, we've got some controls here and there, and now the next step is to make, trying to find it, the 1 volt per octave. It looks like in the last builder's live stream on this circuit, I was actually talking about it already. I only just cleaned this now. I talked about it already. It's explaining what is going on and why there are certain situations. There's an offset adjust, and this is good news because it means that I don't actually need to add an offset to it, but we're not going to bother adding the offset. So what we're going to do is we're going to make this part, which is going into an inverting op amp. This is something, I may as well explain it now because you might not have seen it from the other builders live streams, but this is basically an operational amplifier. You get in synthesizers, there's usually quad or dual or single operation amplifiers in a single chip, and the most common ones are TL071s, TL072s, that's a dual, and TL074s, which is the quad, and that's what these are. This is the thing, and you can see that triangle. This is the pin out. Basically the quad one, this is the TL074. There's 4 op amps, operational amplifiers, and you can use these for whatever you want on one chip. And you can see, look, there's there's that. So what we need to do is we need to figure out the different pins. So there's a pin going into the minus, the inverting input of the op amp. That's pin 2. So you go there, and then you're able to figure out what bit goes, what resistor, what wire goes where around the op amp via this. And then also remember, whenever you put in an op amp, to power the op amp, so you've got the VCC plus, which is the positive supply, and the VCC minus, which in a synthesizer is the minus supply. So usually with a TL074, TL072 or whatever, you put that as plus 12 volts and that as minus 12 volts, and then the ground is usually inside the op amp. Like in this instance, it's an inverting amplifier. So you've got the positive input, which is called a non-inverting input. Send that to ground. Send it off to ground. And if you're not sure how operational amplifiers work and stuff, there's some really good videos on the internet. Just search up what's an operational amplifier. How does an operational amplifier work? This is basically what synths. They're basically operational amplifiers, just buffering loads of just different combinations of resistors and capacitors and stuff, and other fancier things. But you know, there's a lot of these around, so you'll get to know them if you're building this stuff. So what we need to do is let's just jump in. So we've got the input. Here's an input right here. I've got another bit of Lego here. Here's the input. We got this wire. Gonna send the ground to ground. Ooh. I'm gonna get rid of the oscilloscope now. I don't need it. It's in the way. Ooh. Yeah. Bye. So putting it to ground. So we need to. Luckily, I have. So if you see here, this circuit right here is a TL074. It's a quad op amp. And basically I've used 2 of the op amps on one side. You see all of the stuff on this side is because I used the 2 op amps to actually make the output filter. And this is what we spoke about before. It comes out digital and it goes in, and this smooths it off into a faux analog kind of output. So that's what's going on here. I missed this bit out, it seems. So what we're doing is we're going to use the other 2 op amps here, probably only one, yeah, I only need one, to make the other bit of it, which is right here. So what I'm going to do is try and figure out if I need to, yeah, I need to make, I'm just going to wire that straight via, okay, so I'm going to get some, why do we need 91k? One set, just figuring something out. I'm trying to find a resistor that is saying it needs, which is a 91k. And I'll explain why it needs a 91k. Again, I didn't explain it in the last one, but probably needs a... Where are my resistors? Resistors come with... Oh, where are the resistors? So it seems that I don't actually have many 91k resistors. So I'm just going to explain it anyway. It doesn't hurt to explain this again. So basically, what happens is this is the... It doesn't make complete sense, but this is the input into the pin, into the digital chip. And basically the digital chip can only handle 0 volts to 5 volts. So we've got an issue because 0 volts to 5 volts, basically synthesizers go from minus 12 volts to plus 12 volts. How do you make that work? Well, basically what this is doing is it's taking in a 0 to 5 volt CV, but you can plug in any voltage you want actually, and we'll explain how that happens in a sec. And basically it goes into this non-inverting op-amp circuit, and I'm trying to think of how I described it last time. So you'll see that there's 2 resistors that you need to take note of here, and we'll ignore one resistor really quickly. So ignore this. I'm trying to cover it. Covering that. So it goes into this resistor. This is the first resistor in the inverting op-amp circuit. You'll notice that's there, and then you'll notice this one is there. Basically this is the feedback resistor, and basically that goes from the output to the input again of the op-amp. And in order to make it So you're able to, you basically can amplify or limit, unamplify. I don't know what the word is. Amplify it. I don't know. You can amplify the voltage. So if you put 5 volts into here, basically how it works is this resistor and this resistor acts as a ratio. So if this resistor is 100k and this resistor is 100k, then you end up with the same voltage coming in and the same voltage coming out. It's not exactly the same. We're going to talk about that in a sec, but let's just say it's the same voltage. So you put 5 volts in, you get pretty much 5 volts out, but you don't. Take that into account. But the thing is this is an inverting op amp, and what that means is basically it also inverts it. So you send in 5 volts into this, you actually get minus 5 volts out because it's inverted it. So 5 volts goes in, minus 5 volts comes out. The thing is if you actually increase this resistor to if you increase this resistor to 200k, so that's twice as big as this one, you end up getting twice as much out as you put in, but in the negative. So if you put 5 volts in, you end up getting minus 10 volts out. And inversely, if you actually leave this as 100k and you make this 47k, you put 5 volts in, you get 10 volts out, and it works like this. So if you think about it, I'm doing a very bad job this time of describing this, I've got to be honest. So this resistor, you think of it like, because they all look the same. If you search up an inverting op amp circuit, they'll all look the same. So let's say this is 100k and this one is 100k. That's a 1-to-1 ratio, yeah? And that means what you go in comes out, but negative because this is inverting. So if you make this a 200k, that's 2-to-1. That actually works out. So you go in 5 volts, you come out minus 10 volts. But if you do it also 0.5, well, if you go oh no, if you change the ratio, so this is 100k, this is 47k. I'm doing a very bad job of describing it today. You never know. You get the same ratio, so it's 2-to-1. You end up coming out the same thing. So what is happening here is basically the world isn't perfect. So in order to get a perfect 1 volt per octave, because this is listening to 1 volt per octave, and you want to put in 5 volts. Let's say you put in a 100k resistor here and a 100k resistor here. They're never going to be exactly 100k. It's a fact. So it's always going to be slightly out, which means that your 1 volt per octave isn't going to be perfect. So what Electric Druid has done here is he's actually put this as a 91k resistor, but then made a 20k trim potentiometer. So put these both together, you have a resistor. So you have 91k plus 20k, you have 111k. But you can adjust this to 0k, so you end up being 91k when you add them together. Or when you get the fine center ground, this ends up being 100k altogether perfectly. Or it ends up matching this perfectly. But we'll look at that in a bit, and that just made 0 sense at all. But there's a problem here. And no, the diodes aren't for clipping, and we'll talk about those in a second. However, there's an issue here. You fire 5 volts into here, it comes out minus 5 volts. Yeah, it's a problem because that'll explode, that'll burn out the pin, that'll burn out the chip. If you end up sending in 0 volts into this, it actually becomes 0 volts coming out. That's because it's inverse. So you send 0 volts in, it comes out 0 volts. You send 5 volts in, it comes out minus 5 volts. What we need to do is we need to sort of offset it. So this 5 volts actually becomes 0 volts, and this 0 volts actually becomes 5 volts. I know, it's a head fuck. You can actually do that. Language. So how do we do that? Well, this is how Electric Druid does it, and he does it in a number of his different circuit designs. Is what he does is he uses here's another funny one, minus 5 volts. You see that? That's minus 5 volts. So basically this is acting as a mixer. You've got another 100k resistor coming in here, and it's basically mixing these two together. And this is how you make a mixer in a modular and stuff. You actually send 2 of these in, and it mixes both of these together, so you get the mix of the output. So what this is doing is if he sends minus 5 volts into here on its own, it actually comes out as plus 5 volts. You end up with plus 5 volts going in here. So it actually offsets it upwards. This doesn't make sense at all. I should have described this better, but whatever. So let's say you send in 5 volts here, and if you didn't have this, you end up getting minus 12 volts. However, if you offset this up, you actually get 5 volts, you actually get 0 volts. It's weird, isn't it? And if you send in 0 volts into here, you actually end up getting 5 volts into the chip. So what he's done is he's in the code, he's inverted the pitch. So the more voltage going into the chip, you end up getting a lower note, and if you send in lower voltage, you end up getting a higher note. That's because he's taken into account this inverting op amp. And this is a solution to reduce the amount of circuits and chips required to actually make this work, because you can actually just basically wire an inverting inverting op amp and then another inverting op amp together to actually bring it back to the original voltage. So you invert it and then you invert it again. I know this probably doesn't make sense. Does that make sense? Is anybody understanding it? Oh, a couple of them. But this is where the diodes come in. So let's say, for instance, you accidentally send in here minus 5 volts. Ooh, minus 5 volts. Yeah. If you haven't got the offset, that's fine. You end up with 0 volts because you've automatically offsetted it with the actual CV going in. However, if you also do this when it's minus 5 volts, so you've got minus 5 volts and minus 5 volts going in, you end up getting a massive plus 10 volts going into this, and then that burns the chip out. Pop. And this is what these diodes do. These are protection diodes. These are just diodes that are actually wired opposite. So basically, think of diodes. Diodes are like, have I got a diode to hand? Give me a diode. Oh. We've got a diode here. This is what a diode looks like. You can see that, you can't see that. That is a diode, a little lovely yellow thing, orange thing. This is what you usually find in a modular. You usually find 2 different types of diodes. You find Zener diodes, which is something we won't talk about today, and you find signal diodes. Oh no, you also find power and rectifying diodes. These are high power ones. You see they're the big and black with a silver ring. We won't talk about those either. We're going to talk about these, and these are signal diodes. The most common 2 types of signal diodes used in synthesizers are 1N4148s and T914s. In essence, they're pretty much, as far as we're concerned, the same thing. If you find that in your data sheet and you want to build something and it says 4148 and all you have is a T914 signal diode, just use it anyway. It doesn't make a difference in most situations. So you can think of this as a one-way road for electronics. So there's a black line at this side, and this black line actually correlates to this black line on the symbol. So this is the symbol for the diode, and there's a black line. There's a black line. So you think of it like that. So we don't need to look at the physical one anymore, because now you know that this top diode is facing upwards. There's a black line. There's a black line. So let's look at the diode symbol for a second. So think of it as an arrow. Probably doesn't mean an arrow. It probably does. So this is the way that the one-way road is actually moving. So all the cars, which is the electricity, is driving this way. And the thing is if this is driving to ground, if this was ground, so it was all driving to ground, all of the electricity would just run out and be like, oh, hello, let's all drive down here. Let's drive down this road. It looks like there's a really good second-hand shop at the bottom of the road. Let's drive down there. But the thing is these are actually wired in backwards. So instead of a ground here, there's a plus 5 volts. And and this is the opposite. So let's say there was a 5 volt here. The cars will be driving this way. Yeah, they'll be driving this way. They'll be like, oh, let's go over here. Let's go to this thing. There's a really good gig or something. Yeah, but that's not the case. There's a ground on the end of this diode. So in usual situations, this is just doing its thing. These are not doing anything at all until you end up going beyond plus 5 volts, or you go below ground. Below ground would mean the minus voltages. The thing is when that happens, so let's say this actual circuit point right here ends up becoming minus 5 volts, which is going to damage the chip, then actually the ground has a let's talk physics here, which I don't really know. I don't know whether this is the right term. It has more potential energy. We're not going to say that. The ground is a higher voltage. It's weird thinking ground is a higher voltage in something than the actual -5 volts. So the ground cars are actually going to drive over here. They're going to drive and actually counteract the -5 volts to actually make it ground. It's like, we're not going to let this happen. And likewise, if there's 10 volts, 10 volts is above 5 volts, so it's going to drive up here. It's going to be like, so anything above these voltages ends up getting completely eaten up by the diodes. Yeah, if that makes sense. I tried to say that in reasonably layman's terms, so please excuse me if that sounded completely ridiculous and wrong at the same time, but sometimes you've got to describe it wrong to make sense in the simplest form, maybe. I don't know. Here we go. Everybody's saying, these are other ways of saying it, so yes. You can also think of these as bags of balls. Imagine electrons are balls, and if there's no balls here, all the balls are going to fall out. But if there's too many balls here, then the balls ain't going to be allowed to get in. Too many balls to talk about. But yeah, so that's how this circuit is working. I think I've described that in a reasonably bad searching. And also, yes, Stevie Harris has also said this is how distortion clipping works. It's exactly how distortion clipping works. And I don't know whether you've ever looked at distortion clipping, but basically what happens is you do the same circuit. You've got but usually only on one side. Let's say we've got the diode, and there's 5 volts, and also rectifiers and stuff. But you've got a circuit coming in here. Yeah, you've got a voltage coming in here. Imagine oscillators and stuff being really quick versions of this. It's all the same in the end, but this is like a sine wave coming in. Let's say this sine wave is coming in. The top of the sine wave is what, like 4 volts, and the bottom of the sine wave is like ground. Yeah, you got ground. This is going to come out because this is wired to 5 volts. So I've just done this. No, I haven't. Have I done this the wrong way around? Have I wired it the wrong way around? Sorry, I don't want to tell you the wrong thing. Have I just done this the wrong way around? Ah, my brain's not working. No, I'm not. I'm doing this reasonably right, but usually there might be ground. So yeah, this would actually come out exactly the same. It would come out as 4 volts and ground. Maybe there'll be some voltage loss. I can't remember. This is off the top of my head. However, let's say this actually comes in at 6 volts. Ooh, 6 volts. Yeah. What actually comes out is the 5 volts. But then everything above it, the bit above it, the actual part above it that is at 6 volts, this bit on the circuit doesn't come out. That gets eaten up over here. All the balls, all the electron balls are rolling out into here. So what you actually end up getting is a clipped, and this is why it's called clipped, because you'll imagine it doesn't sound like, when you hear something clipped, maybe it doesn't sound clipped. This is a way of turning a sine wave into a square wave, by the way, but you actually end up getting like this. So you get a sine wave up to 5 volts, and then it clips, and then it goes back down, and then it clips. So you end up being a 5 volt output, and the top, the 6 volt, the volt on the top is basically chopped off. It's trimmed off. Anyway, so that's clipping and also diode voltage protection, and why there's a diode voltage protection in this circuit right there. So I'm going to have to get this done really quick because my washing's nearly done, so I'm going to have to go back pretty soon or I'm going to get nagged, but I'm going to try and get this wired up in the next 20 minutes. So we're going to go back to this pin out of the op amp, which is basically here. This is this circuit. This chip's that one. What we're going to do is we're going to try and copy this circuit right here. I don't know if I can lead it. Oh, there we go. So what I'm going to do is I have the output. This is the jack socket. That's going to be the CV. That one right there. We're going to plug that right here. I'm going to put that there just for shits and giggles. And then we're going to have, I'm not going to bother with this trim, purely because I can't find a 91k, and we're just going to hope that it's going to be relatively in tune. We're going to wish it's a perfect world, and I'm just going to use a 100k resistor and a 100k resistor. It's a perfect world right here. Yeah, just imagine that. So this would mean that if in the perfect world you fire in 5 volts, you get out what we said, but you get out the same. However, in a non-perfect world, not all resistors are the same, not all op amps work perfectly. You end up okay, so what we're going to do is we're going to wire in this to the non-inverting pin, which is actually pin 13. We're going to wire that pin 13 over to the actual input. This is 100k, so this is a perfect world. And then this 100k right here goes from the inverting to the output, and the output is there, which is pin 14. So we need to wire it from pin 13 to pin 14. Literally just a 100k resistor. Like that. Boom. Bish bosh bash. And then right here you can actually see there's a 4K7, and I think that's actually why there's a trim pot here, because you're sort of limiting it a bit. But we'll see what it does. I'll just plug in 4K7 in there. So 4K7, and this is going. Oh, it's getting a bit busy over here, but from the output there's a 4K7. I'm just wiring it there just for shits and giggles. You can't quite see it, but there's a 4K7. Now we need to add these diodes. Actually, right now we don't need to, because I'm only going to use an Arturia BeatStep Pro that is going to give me these voltages. So what I'm going to do is I'm going to get these 2 diodes going. There's one from earlier. Oh, give me a diode. You can also use LEDs for this, and that might be actually an interesting thing to show you. When you're going past the tolerances, the LED will light up a bit. But right now we're just going to use this because we're not actually in this video going to go past the tolerances, because I'm using a BeatStep Pro. So, ooh, damn it, where's my tweezers? Which are my tweezers? So I need to send this from ground going to the output. Ooh. And then, oh, I'm just going to wire it. Oh no, I'm going to, sorry, I'm getting really messy. This has got really messy. And then it's got to go to plus 5 volts. Plus 5 volts is over here. God damn. Sometimes I'm on top of my neatness, other times I'm really not. We don't actually need this bottom one. There we go. Right, so next bit. So in order to make this work, we need to make this minus 5 volt supply via 100k. Luckily, whilst I was doing this, I actually wired in, and I spoke about this before, I'm not going to touch on it again. It's basically, this is a 7905. It's a minus voltage regulator. It regulates voltages down to minus 5 volts. So it needs to be a minus voltage going into it. So the minus 12 volts is going into it from the minus 12 volt line, which is over here, and it's coming out as minus 5 volts. This is going to get very messy, but whatever. I'm just going to get the job done. Can't remember the pin out. What is the pin out of it? Is that really the output? Is that the output? I find that hard to believe. Sorry, I've just got to double check the 7905 pin out because I can't remember it. I know a lot of pin outs though. 7905, give me 7905. Oh yeah, it's the output. Pin 3 is the output. Okay, so we've got the output. I'm going to plug that, put that here. Now I need another 100k to actually make it mix again with the same ratios. Not going to make sense, but I gotta do it. Oh, god damn it, where's my tweezers? Oh, I missed my tweezers. Right. So now I've wired in the -5 volt offset. So technically, if I plug this in to the input, which is, where's the input? Which one's the input? Note CV pin 10, which I have actually set to ground here. No, I haven't. I've set to. Huh? What have I done? This is really low. I didn't realise it was so low. Oh. Whee! Oh, right now it's at its highest note. I'm trying to figure out why. Maybe this -5 volts isn't actually working. What have I done wrong? Should be low. Let's plug it in and unplug this -5 volt. One sec, the 7905 doesn't appear to be working. I haven't got my multimeter. I don't know where it is. Just checking something. Input, common, output. Now why isn't a good way of checking if there's any voltages ever is licking it. So I'm gonna, I can't find my multimeter. There's definitely some juice coming out of it. Why isn't that going? I think I've sorry, I'm just trying to figure out what I've done wrong. 4K7 is going out of there, that's going into the output. Why have I made it so complicatedly confusing? Is anybody looking? The ground pin. What a plonker. Yes, I forgot about the ground pin. Pin 3, the pin 3, which is the non-inverting input, needs to go to ground. Oh, forgot about that. We all make mistakes, especially plonkers like me. I'm using the longest wire ever because I've just completely given up hope on this, the neatness of this breadboard. Now it should be the lowest note again. Yes. If I unplug the -5 volts, yes, finally. Okay, so the circuit works. Now what we need to do is actually plug something into this to see, before you lick the wire, make sure it doesn't have COVID. Very good point. Right, so what we need to do now is we need to plug in an Arturia BeatStep Pro. Why do I even need to say Arturia? Just BeatStep Pro. And I've just got to find one. God damn it, where's my tool belt? Like somebody said just a second ago. BeatStep Pro. Right, okay, okie dokie. Right, we've got a BeatStep Pro. It's a bit out of shot, but we don't need to be so close up anymore, so let's see what we can do. Right, okay. Yeah, the BeatStep Pro, I've got to be honest, I'm not. I love it. I have a number of Beat Step Pros, and it's always just the thing to go to. It's just the right amount of simple and not simple. It's pretty snazzy. Right. Anyway, so what we need to do now is plug it to the pitch output. Oh shit! Try not to break anything. Pull anything out of the wires. Okay, so what we're going to do now, plug it in. Right, let's see what happens. Oh yeah. You can notice it's not in tune, and that's because we haven't added the trim pots. Do I add the trim pots? Trying to think if I have a trim pot. Oh, I haven't got the right resistor. What could I use? I could use just a 200k. Where's my 200k's? Right, this is going to take a second, but I reckon I'll be able to get it in tune just using the wrong things. Come on. Ooh. Right, anyway. Okay, so we've got a trim pot. I'm basically, because it's very out of tune, I didn't realise it was going to be so out of tune. I'm trying to circumnavigate what I've done because I wasn't really focusing. Here we go. So there's this wire going to there, and then I'm going to remove this. I'm going to get in tune by basically just adding a massive trim pot instead of a mini one. So what we need to do now is I need to just twist this until it's reasonably in tune. What I'm going to do is I'm going to make on this really quickly C. I'm going to start C and then C, going up octaves. No, C, C. So now it's going up 4 octaves. I've just whacked in 4 octaves of C, and now I'm going to try and tune it so it's in tune. So this should be octaves. Oh god. The issue is with using a very coarse trim pot is you're taking into account, you have to take into account the mechanical limitations of it, because basically you can hear that it doesn't sound too pretty. That's because you're using a massive trim pot to do a very accurate job. So it's not going to sound pretty, but it's reasonably in tune. Well, it's not, but we'll just treat it as... That's not in tune at all. It's impossible. I'm gonna try a different trim pot. 100k. 100k. Let's try it. I will get there. So it's just, like I said, using big coarse trim pots to do very accurate jobs is somewhat problematic. Ah, no, I can use that. Okay, I found a solution. Fingers crossed. Okay, so I found a solution to it. So what I need to do is I found an 82k resistor. So 82k plus 10k. We've got ourselves 92k, which is near enough 91k. 1k donkey. Oh god, it's got so messy already. Where's my 10k's gone? Where'd I put my 10k's? What the fuck? Language. Okay, 10k. Ooh. This is getting fiddly now without the old tweezers at hand. Where's the... Oh no. 203, 30, 204. 203 is 20k. Right, we're probably going to have a better chance of tuning it now. So let's give it a go. Let's give us a go. No, it doesn't seem to be wanting to tune. That's a bit weird. Maybe I've got the notes wrong. I'm trying to get in tune, by the way, and it's not doing what it's wanting to do. So... Nah. Nah, it's well out. There's something drastically wrong. I'm gonna have a look at the comments. Still think that there's definitely ground on the minus. You can see it right there. That wire, that little furry, that little bloody thing. You can see it. How strange. It just makes me think that Yeah, the chip has glide. I was going to hit that soon, but it's 13, pin 13. I've currently got it wired to ground, so it isn't doing anything. Very strange. It's just not really playing in tune. I can't figure out rightly what exactly is the problem. Oh, no, that won't make a difference. 100k, 100k, 47k, 10k. Oh, I'm gonna give it one more go, and usually situations like this is go home, chill out for a moment, get back on it. There's some really loose things going on somewhere. You can hear it's not a very happy note, and that's down to the fact that I think something's loose. Not sure what it is. I've literally swapped the 20k to a 100k to try and see if it's further along the actual. Something's very loose. Caustic, I was listening without the bit crush for a second. I just realised it was very quiet for everybody. I can't really turn it up much louder, but without the bit crush. Okay, so there's a few issues. The issues being it's very noisy. The signal is being affected somewhere. It's not very happy. That's probably down to the fact that it's a mess, and I probably need to rebuild it and test it. Plus, there's no filtering capacitors, no decoupling capacitors, and stuff like that, which will probably add to the issues that we're listening, which is like not perfect note. You're hearing it a bit loose. The other thing is I swapped it for a 100k trim pot instead of a 20k trim pot, which is what it says on the datasheet. However, I couldn't get the right note with the datasheet one, so I flicked it to a bigger trim pot. Seems that's solving the problem. But maybe I'm being stupid. I'm not sure. Usually I'm being stupid. It's usually being completely stupid. So there's a few things that I need to do to fiddle with it. It's usually, this situation is quite a boring thing. I'm going to measure what the resistance is on that trim pot, sort of get a feel for it. Actually, I'll tell you what, I know where the bloody, when I knew where I was, I just went for it. I knew where it was. I just didn't look last time. Oh, what am I doing? So I'm going to quickly measure the resistance of this trim pot to figure out about how far it is off 20 volts, off 20k I mean. Ooh. Where did we end up at? Oh no, I'm touching it. About 36 kilo ohms. So that means that is about. So that means that this resistor overall is about 120k when it should be about 100k, which is a bit weird, but whatever. I'm probably gonna take this apart, rebuild it, and if the same problem occurs, then look into it further, but likely it won't, and stuff like that. But yeah, that was a bit of problem solving. Hope it was enjoyable. If you want to see more of these, then they are available on the Patreon. Like I said, I accidentally clicked to make this public for some reason. I just clicked on the stream and said start streaming, and I didn't realise it wasn't public, but whatever. So yeah, anyway, I'm gonna start this again at some point this week after the 1000 oscillator mega drone is done. I can't wait for that. Can't wait for it to be finished. It's been taking up so much time in my life. And then yeah. Maletti, yes, they do share the code. So if you want to build it yourself and use the code, then by all means do it, and then you can also modify it. However, the thing is I'm designing this for a kit, for a module kit. So, you know, obviously, you can't really circumnavigate it by the rules, which is fine. It's the thing. But anyway. Yeah, anyway, I hope that was fun. I've got to go and take the washing back. I go to bed. Go back to work in the morning. So, thank you very much, everybody. Have a lovely evening. Take care. Peace out. Peace out. And remember, there's a Look Mum No live stream on Twitch /Look Mum No Computer on Wednesday. And also, I'll be doing, I haven't done this last month, live streams, musical live streams much on the Patreon. Because I've been so busy with the 1000 oscillator mega drone, but I'll be back to normal schedule pretty soon. Anyway, take care, everybody. Bye. Toodly doo. Toodly toodly toodle pip. Toodly doo. Bye. Bye to bye. How do I turn this off? It's on a completely different page. I have no idea what I've done. It's like, how did this happen? Exit stream. Why won't it let me exit the stream? It's all gone funny. What is going on? I don't know. Can't seem to. It won't let me leave now. I think YouTube's probably changed its live streaming thing, and I've not realised, and I've clicked all the wrong buttons. It just won't let me end it. What the fudge? Why isn't it? Where's the end? They've taken the button off. Oh. Literally just... Well, I can't end it now. No, I'm joking, but I better bloody be able to. How are you supposed to... I don't know what I've done. I've actually made a highlight. Where's stop? Oh, I know what they've done. Okay, it makes sense now. I think I've figured it out. But I don't still understand how it made it public. Basically, I've managed to circumnavigate to a page that is built for OBS. So I use OBS to stream my videos, and for some reason now, whenever I click on start streaming on OBS, it didn't happen before. This is the first time it's happened. It starts streaming on YouTube. Very strange. So if I click stop streaming on OBS, I should go. So take care, everybody. Bye. I've got to figure out what YouTube's done now. It's completely changed.